Yes, good morning to all. Am I audible?
Yes, sir.
Yes, sir.
Yes, okay. So I'm going to share the PPT. Right. Is it visible to you?
Yes, sir.
Okay, fine. Continuation with yesterday's class. Okay. What we have discussed yesterday, that is derivation of the Schrodinger time independent wave equation. Right. So that we'll see just little bit and we'll continue with the topic. Right. So this is the equation, derivation of time independent wave equation. For that, we are utilizing a vibrational, right, wave motion. Whenever object will be present in vibration, so that may possess moment, right? So the wave motion or wave function that will be depends on x and t. For this, the second order differential equation can be written in terms of x and t. Dou square w by dou x square is equals to 1 by c square into dou square w by dou t square. But here w is the motion of the particle that can be defined as f of x into g of t. This is into f of x into g of t. Okay, right. So then g of t can be defined as again a into sine 2 pi nu t. A into sine 2 pi nu t. Right. So the w will be differentiate with respect to x two times. Right. The w will be differentiate with respect to x two times. That will be substituted here. Right. So then the same w will be differentiated with respect to time two times. That will be substituted here. Right. So just simply seeing that. So this is the w equation f of x into a into sine 2 pi nu t. Once differentiation with respect to t, that is
సార్ సౌండ్ వినిపించట్లేదు చిన్నగా వస్తుంది
as voice was not clear.
వినిపిస్తుంది కానీ చిన్నగా వినపడుతుంది
Okay. Okay, just wait. Just wait. Right. Is it okay now? Yes, my voice was clear.
Clear, sir.
Okay, fine. So here the W can be defined as f of x into a sine 2 pi nu t. Once this W should be differentiate with respect to time. So we will get one equation, that is the equation number 4, right? Means two times, after two times differentiation, we will get this equation. And the same function, that is W is equals to f of x into g of t, that will be differentiated with respect to x, right? Here little bit correction is there. So this is not t square, this is the x square. Here dou square w by dou x square is equals to dou square into f of x by dou x square into g of t. So therefore equation 4 is substitute in equation 1. Equation 4 is substitute in equation 1. So we can get that this x values should be substituted left hand side, and this t values will be substituted. These are the t values. This will be substituted right hand side. So then we'll get this equation, right? So just simply simplifying of this equation, we will get the solution of this Schrodinger wave equation. Okay. So after substitution, this some de Broglie concept was applied here, right? De Broglie concept, that is nu is equals c by lambda. So instead of c square by nu square, we can draw it to lambda square, right? So then from the de Broglie concept, lambda is equals to h by mv. So that is equals to h by p. Therefore, lambda square is equals to h square by p square. Lambda square is equals to h square by p square. So this lambda square will be substituted in above equation. This is the equation, and here the kinetic energy will be T is equals to half mv square, but the total energy is equals to kinetic energy and potential energy. A is equals to T plus V. Therefore, T is equals to E minus V. T is equals to E minus V. Therefore, E minus V is equals to half mv square. Therefore, 2 into E minus V. That means this 2 will be come left hand side is equals to mv square. Then multiplied with m on both sides, we'll get m square v square. That becomes p square. Where the p square value is there in the previous equation, we are going to substitute this one. Okay. So that is minus 4 pi square by h square into p square will be there. In place of p square, 2m into e minus v, then into f of x, right? So just multiplying of this equation, we will get one new equation. This is called Schrodinger wave equation. That is in terms of only x direction. Dou square into f of x by dou x square plus 8 pi square m by h square into e minus v into f of x is equals to 0. Instead of f of x, we may use psi, that is a wave function. The above equation can be written as, right? And also that should be applicable for three-dimensional particles, right? Three-dimensional system. So we can write the Schrodinger wave equation will be like this. That is dou square psi by dou x square plus dou square psi by dou y square plus dou square psi by dou z square plus 8 pi square m by h square into e minus v into psi is equals to 0. So this is the Schrodinger wave equation. Here there is no time factor t. So therefore it is a time independent Schrodinger wave equation. So further we may utilize this equation, right? Further we may utilize this equation to get the solutions of hydrogen like atoms. Okay. So then the particle of one dimensional box. We are going to discuss that a particle of one dimensional box, right? So whenever the particle will be moving in one direction, that is along with x direction with the box length of 0 to a, right? So simply see, these are the two axes, right? The particle will be moving along positive x direction. This is the positive x direction. the mass of the particle becomes a small m. The small m mass of particle is moving along this positive x direction. These are the box length. This is a one-dimensional box. That is the box length from 0 to a. This is the box length 0 to a, right? So then the potential will be outside the box, that becomes infinity. The potential will be inside the box is 0, that is v is equals 0, and outside the box the potential will be infinity. With the help of these conditions, we are going to determine the wave function and energy of the particle. Wave function and energy of the particle. We already told that some of the dynamic properties we are going to discuss, in which one of the property, that is the energy. Whenever the electron is revolving around the nucleus, what will be the energy of that particular electron? That energy can be determined. Here we are saying that the particle will be moving in along x direction. At that time, what will be the energy of the particle? The particle having mass is m, right? So with the help of utilization of the Schrodinger wave equation, we will get the solution of the wave function and the energy of the system. So that is the conclusion of this particle in one-dimensional box. Whenever the particle will be moving in a one-dimensional box, these are the conditions. So whenever the v is equals 0 means inside the box the potential becomes 0, and outside the box the potential becomes infinity. Inside the box means what? So this is the 0, this is the a. In between 0 to a the potential becomes 0. That's why 0 is less than x less than a. Or when v is equals to infinity means 0 is greater than x is greater than a, right? So the x value that will be greater than a at the time, greater than a means this is, at the time the potential will be infinity. Here greater than less than 0, so that means the potential becomes infinity. In between these only the potential will be 0. These two are the boundary conditions. With the help of these two boundary conditions, we are going to prove a particle of one-dimensional box. Whenever the particle which will be moving in a one-dimensional box along with positive x direction, the energy and wave function should be determined, right? So see, the Schrodinger wave equation for x-axis only, right? So whenever we derive the Schrodinger wave equation, that should be applicable for three axes. Previously we wrote that along x direction only one axis will be there. Only one axis, that is particularly x-axis. That's why the Schrodinger wave equation can be written as dou square psi by dou x square plus 8 pi square m by h square into e minus v into psi is equals to 0. E minus v into psi is equals to 0. This is the equation, Schrodinger wave equation. So we have to apply the conditions. Inside the box, the potential V becomes 0. Therefore, this V becomes 0. We'll get this is the equation, right? And further, we simplify that equation means the potential V is equal 0. Therefore, we can get a second order differential equation, right? So this is the equation here, V is equal 0. This will be move right hand side, right? So this is not equal 0. Don't write this one. Just dou square psi by dou x square is equals to minus 8 pi square m by h square into e psi. Means this will be moved. This entire term will be moved right hand side. That becomes negative. That becomes negative, right? So therefore, dou square psi by dou x square is equals to minus alpha square psi. Here, what is the alpha square means? 8 pi square m by h square. So this is the thing will be there even here e. Alpha square means 8 pi square m e by h square. So some little bit errors are there. You may correct, right? See, this is the entire term that is 8 pi square m by h square into e becomes alpha square. Minus as usual will be there, psi as usual will be there. The remaining all the terms becomes alpha square. Alpha square is equals to 8 pi square mg by h square. 8 pi square mg by h square. Okay, right. See that equation. So this is the equation dou square psi by dou x square plus alpha square psi is equals to 0. This is a second order differential equation. Dou square will be there, then terms alpha square. So means this is the second order differential equation. The solution of second order differential equation can be written as the solution of second order differential equation can be written as this one. That means psi of x is equals to psi of x is equals to a sin alpha x plus b cos alpha x. A sin alpha x plus b cos alpha x. This is the solution of psi of x. Whether the solution is correct for this second order differential equation or not. So just we'll see. Whether it will be correct or not means by simplifying of this equation, whether we will get a similar second order equation or not, right? So here is the in the square bracket equation will be there means this is the solution psi of x. If we do if we do if we do a differentiation with respect to x, right? Just see this is the things. These are the things you have to see. Right. Only these things you have to see. A into sine alpha x plus b cos alpha x. Okay. Now we are going to differentiate this one with respect to x. A should be constant. Cos alpha x differentiation, yeah, sine alpha x differentiation is cos alpha x into instead of x alpha x will be there. Again differentiation we will get alpha. Then cos differentiation that is the minus sine minus b into sine alpha x into alpha. Then one more differentiation that is a into cos differentiation that is minus sine alpha x into alpha. Alpha alpha becomes alpha square minus b into sine differentiation is cos alpha x into alpha. Already alpha is there, that's why alpha square. Therefore, we can get minus alpha square becomes common. We will get a sine alpha x plus b cos alpha x. This a sine alpha x plus b cos alpha x is the psi of x. Therefore, dou square psi by dou x square is equals to minus alpha square psi x. So this is the second order differential equation that will be same, right? So therefore, we have to use the solution of psi of x is equals to a sin alpha x plus b cos alpha x is the solution for this second order differential equation. So when we have the solution, we are going to apply the boundary conditions. What are the two boundary conditions will be there? What are the boundary conditions? These two are the boundary conditions. The particle will be moving along with x direction. One is x is equals to 0 and other one will be x is equals to a. This is the one condition and this is the other condition. If we can apply the condition number 1, if x is equals to 0, if x is equals to 0, at the time the wave function becomes 0. Psi becomes 0. Therefore, psi is equals to a sin alpha x plus b cos alpha x. That is the solution. But psi is 0 means 0 is equals to a sin 0 plus cos 0 because x is equals to 0. x is equals to 0. That's why sine 0 becomes 0, cos 0 becomes 1. Therefore, b is equals to 0. We will get one condition, that is by applying condition number 1. One of the boundary condition should be applied. We will get the solution, that is b is equals to 0. B is equals to 0. Similarly, the second condition, that is when x is equals to a, even at the time also psi becomes 0. That we'll see in the next equation. Okay, right. So here are the second condition, that is x is equals to a. We are going to substitute. When x is equals to a, the wave functions becomes 0 even in this time also. Therefore, the solution was psi is equals to, psi means 0 is equals to a sin alpha a plus b cos alpha a, right? So, but from the first condition, b is equals 0, we know that. Therefore, a sin alpha a is equals to 0. Therefore, sin alpha a is equals to 0. This is the condition we will get. This is the condition we will get, right? Is it clear? Are you able to understand? Two boundary conditions are there. One is x is equals to 0 and x is equals to a. These two conditions should be applied. Once we substitute x is equals 0, we will get the condition, that is b is equals 0. In this case, x is equals to a, we will get the solution, that is sin alpha a is equals 0. But we know that situation, that is sin n pi is equals to 0. When you substitute the n value becomes 0, 1, 2, 3, like so on. N is equals 0 means sin 0. Sin 0 is 0. N is equals to 1. 1 into pi means sin 180. That is also 0. N is equals to 2. That is 2 into 180 means 360. Sin 360 also 0. Like that, whatever is the n value you may you will get the solution becomes 0. That's why sin n pi is equals to 0. Here previously sin alpha a is equals 0. Therefore, we can write the right hand side value becomes 0 for both these situations. Therefore, we can write sin alpha a is equals to sin n pi. Sin alpha a is equals to sin n pi. Right. So therefore, by utilizing anti-sign on both side, we will get anti-sign on both side, we will get alpha a is equals to n pi. Just simply we will get alpha a is equals to n pi. Okay. Alpha a is equals to n pi. Therefore, alpha is equals to n pi by a. Alpha is equals to n pi by a. Okay. So from equation number 3, what is the equation number 3 means? So psi is equals to a sin alpha x plus b cos alpha x. A sin alpha x, alpha value we will get, that is n pi by a. Alpha x means that is n pi by a into x. Now we want only just simple a. If we get a value, that is the equation of wave function psi, right? So how we'll get a value means by doing normalization of psi. By doing normalization of psi, we will get that a value. So that is the normalization of psi. That means integral of psi square into d tau is equals to 1. So this is the one psi. This is the another psi into d tau is equals to 1. Therefore, by multiplying this, a square integral of sin square n pi by a into x into d tau is equals to 1. But sin theta is equals to, what is the definition means? Sin theta is equals to, sin theta is equals to 1 minus cos 2 theta by 2. 1 minus cos 2 theta by 2. So this is the formula, cos 2 theta formula we can apply here. That is sin square theta is equals to, sin square theta is equals to 1 minus cos 2 theta, 2 into n pi by a into x. This is if we may consider theta, if we may consider theta, sin square theta means 1 minus cos square theta, cos 2 theta by 2. Cos 2 into theta means n pi by a into x. So then further this may simplifies, we will get 1 by 2 gets separate and cos 2 theta by 2 is separate, right? So cos 2 theta by 2 becomes 0 because whenever the angle substitute from 0 to a, right? So if you substitute these values, if you can substitute the boundary conditions from 0 to a, the boundary conditions from 0 to a, you can substitute the boundary conditions from 0 to a. So that is cos 2 theta will be there. For example, here 0 means entire term becomes 0, cos 0 is 1, right? Right, n pi by a, or upper limit a will be there, substitute a, that is a get cancelled, cos 2 n pi. Again substitute n value, you can get 0. Therefore, the second term becomes 0. So only we will get the first term, that is a square of integral means 1 by 2 take outside, upper limit minus lower limit means a minus 0, that is a by 2. Minus 0 is equals to 1. So this is the integral partner. Integral cos becomes sine. Sine n pi is 0. Already we know that. After integration, cos that will give sine n pi. So either 2n pi or n pi, whatever it, this value becomes 0. Sine becomes converted to the cos after integration. That's why the second term becomes 0. Therefore, a square is equals to 2 by a, then a is equals to root 2 by a. Therefore, this a value will be substituted in the above psi equation. Therefore, psi is equals to, we will get the square root of 2 by a, then sine n pi by a, sine n pi by a, n pi by a into x. This is the solution of wave function when a particle is moving in along positive x direction or one-dimensional box. One-dimensional box, right? Is it clear?
Yes, sir.
Yes, sir.
Yes, sir.
Only two conditions are there, boundary conditions and one second order differential equation we will get from the Schrodinger wave equation. We have to assume the solution of the second order differential equation and apply the boundary conditions. We will get this wave function. We will get this wave function. So further, this is a wave function, that is psi of x is equals to root 2 by a into sine n pi by a into x. This psi will give the characteristics of wave, right? So what are the characteristics of the wave? We'll discuss after completion of the energy. Okay, right. So how we'll get the energy calculation from this, right? So energy calculations means already we know that alpha square is equals to, previously we say that 8 pi square me by h square. ఇది ఫస్ట్ మనం అనుకుంటున్నాం. When we say alpha square is equals this, then only we will get a second order differential equation and we are going to choose a solution of that second order differential equation. And also we will get one more relation of alpha, that is alpha is equals to n pi by a. Therefore, alpha square is equals to n square pi square by a square.
Okay.
From these two equations, left hand side will be same, alpha square will be same. Therefore, we need to equal right hand side, that is 8 pi square m by h square into e is equals to n square pi square by a square. This pi square get cancelled. Therefore, E is equals to n square h square by 8ma square. This is the energy of the particle and this is the wave function of the particle. These are the two solutions for particle in one-dimensional box. This is the wave function and this is the energy. So whenever the examiner may ask the question based on particle in one-dimensional box, you have to write up to the energy. You have to write up to the energy, right? So this is energy is equals to what? N square h square by 8ma square. If you people understand this one-dimensional box, then we can get easily solution of the three-dimensional box. So the same phenomena will be applicable to three-dimensional system. There we will get total energy along with three directions and the total wave function along with three axes. All those data will come with the help of utilization of this particle in one-dimensional box. Particle in one-dimensional box. Before going to that, so some significance of psi and psi square will be there. So we are saying that, right? We are saying that what is the significance of the psi and what is the significance of the psi square, right? Yes. Are you able to see the screen? Is it visible properly?
Yes, sir.
Sir.
Okay, fine.
Yes, sir.
Psi be the wave function. It explains the state of the system. We have psi, so that will be explains the state of the system. But when we do psi square, that will give the finding the probability of the particle. Finding the probability of the particle. Psi we will get from the solution. After getting psi, we'll do psi square. If this psi square becomes maximum, that is known as orbital. Based on the value of psi square, whether it is a orbital or not, we can explain. If the psi square value becomes a minimum, that becomes a nodal plane. That becomes nodal plane. We will get the psi value only, but we have to do psi square. So where the psi square will be maximum, that should be considered as an orbital. Where the psi square becomes a minimum, that should be considered as nodal plane. So that is, if finding the probability of the particle is maximum, that is known as orbital. If finding the probability of the particle is minimum, that is known as nodal plane. Nodal plane. So these things will be explained by psi and psi square. So if we can plot the graph of psi and psi square values, the representation of the psi and psi square that will be seen in the next slide. Okay. Right. So see, so this is the first diagram with the psi diagram. This is the belongs to psi and this is the belongs to psi square, right? So I will wrote equations here. What is the psi and what is the psi square? So see this the left hand side becomes indicates a psi, that is the psi is equals to what? Square root of 2 by a. Square root of 2 by a into sine n pi by a into x. Sine n pi by a into x. N pi by a into x. Psi square means what? Just simply do square of that one, right? Root 2 by a becomes 2 by a. Then sin n pi a becomes sin square n pi by a. Sin square n pi by a into x. These are the two equations, right? Here x will be there. X values we are going to substitute from 0 to a. x values from 0 to a, we are going to substitute these x values. X is equals to 0. That means sine 0. Sine 0 becomes 0. Here we will get x is equals to a by 4. A get cancelled if n is equals to 1. Here we are saying if n is equals to 1, in place of x, substitute a by 4. A get cancelled. Pi by 4 will get 180 by 4 means 45. Sine 45 is equals to some value that will be here. Like that, a by 2 means that is sine 90. So it will be here. Then a by 3a by 4 means we'll get value here. Then substitute a. Instead of x, substitute a get cancelled, sine n pi, that becomes 0. So that's why we will get this type of flat when n is equals to 1. When n is equals to 1. Okay. If n is equals to 2, if n is equals to 2, by substitution of values of x values from 0 to a, again you have to substitute. So, but n is equals to 2. At that time, we will get this type of lobe. One is a positive lobe and other will be negative lobe. This is at a by 2 position. Like n is equals 3, one positive lobe, negative lobe, and one more positive lobe. N is equals to 4, that is two positive lobes and two negative lobes. But in case of psi square, even the negative lobes also becomes a positive because square root will be there. So this is the negative value. This is the negative value. This negative also becomes a positive because of square, right? So like that, all will be positive lobes only. See here. Here n is equals to 1 means the finding the probability becomes maximum only. There is no minimum. But in n is equals to 2, here is the finding the probability becomes a minimum. That's why it should be considered as one nodal plane. One nodal plane. Here two nodal planes will be there. Here three nodal planes are there. So this may indicate the n is equals to 1 may containing only s orbital. N is equals to 2 containing s orbital and one nodal plane will be there. That's why that is the p orbital. N is equals to 3 containing two nodal planes, that is s orbital, comma p orbital, comma d orbital also. But n is equals to 4 containing three nodal planes means that may containing s, p, d, f orbitals. S, p, d, f orbitals. This is the information. This is the information we will get from the solution of these, right? So this is the first cell containing only S. This is the second containing S and P. That is the third containing SPD. The fourth containing SPDF. So how, which may indicate with sometimes K, L, M, N like that. K, L, M, N. K shell containing only S because N is equals to 1. L shell containing 2, that is S and P because N is equals to 2. M shell containing SPD, that is N is equals to 3. Like that, so these are the principal quantum number values which can be obtained from the significance of psi and psi square. So with the help of the significance of psi and psi square, we will get how the orbitals are distributed in an atom, right? In the nucleus, how the representation of the various orbitals around the nucleus, that will be explained with the help of psi and psi square. Okay. So this is the information we will get from this. Is it clear?
Okay, sir.
Yes. Okay. So further, the same concept means the particle of one-dimensional box concept that can be applicable to three-dimensional box, right? See here, the particle of mass m moving along x, y, z directions. Previously, what only along with x direction. Along with x direction, the box length was x is equals 0 to x is equals to a. But here the particle will be moving along with x, y, z directions. That is in three-dimensional with a box length of a comma b comma c. So simply here you may utilize a cubical box whenever a particle will be moving along in the cubical box, right? Whenever the particle will be moving along the cubical box, how the energy will be calculated through this, right? So this is the three-dimensional box. This is a three-dimensional box. This is x-axis, this is the y-axis, this is the x-axis, this is the y-axis, and this is the z-axis. This is the z-axis. Three axes will be there. Along x-axis, the box length was A. Along y-axis, the box length was B. Along z-axis, the box length was C. These are the A, B, C are the coordinates of x, y, z. Therefore, the Schrodinger wave equation can be written as in terms of three axes: dou square psi by dou x square plus dou square psi by dou y square plus dou square psi by dou z square plus 8 pi square m by h square into u minus v into psi is equals to 0. V minus V into psi is equals to 0. So this is the equation can be applicable for all three dimensions, Now we are going to solve this three-dimensional equation. We will get the energy and wave function of the particle when the particle will be moving along with three-dimensional box, right? The same boundary conditions are there. That is V is equals to infinity to V is equals to 0 and V is equals to infinity. That means inside the box the potential becomes 0. Outside the box the potential becomes infinity. Inside the box the potential becomes 0 and outside the box the potential becomes infinity. And also the boundary conditions also applied here, right? So we will get the solution of the psi and energy. So this is the simplification, right? So just what we discussed previously. So the same will be repeated here, right? So what was that? We'll see. Okay. Right. Inside the box, the potential V becomes 0. So that's why E minus V into psi means only E psi will get, because V is equal to 0. This will move right hand side, that is minus 8 pi square m by h square into E minus psi. This is equal to 0, don't write. So because already here equal to is there. This is a equals to means this value will move to right hand side, we will get negative value. Okay. Dou square psi by dou z square plus dou square psi by dou y square plus dou square psi by dou z square. Sorry. Dou square psi by dou x square plus y square plus z square is equals to minus 8 pi square m by h square into e minus v is equals to e minus 3, right? Not equal to 0. Already this will be turns to left and right hand side. That becomes a negative value. Okay. Now here, what we are going to do means, the energy will be there, right? The energy of the particle along three axes is, that means Ex, Ey is there. Here we are using the one of the method, that is a separable variable method. What about that? Separable variable method means whatever are the x terms will be there, we need to separate. What are the y terms are there, need to separate. What are the z terms are there, we need to separate, right? So therefore, Therefore, the energy E is equals to Ex plus Ey plus Ez. So therefore, this energy will be substituted in above equation here, right? So we will get dou square psi by dou x square plus dou square psi by dou y square plus dou square psi by dou z square is equals to minus 8 pi square m by h square into, instead of E total energy, that is Ex plus Ey plus Ez into psi is equal to 0. Ex plus Ey plus Ez into psi is equals to 0. Here we need to separate Ex term, means here Ex will be there and first one x. All the x terms will be separated, all the y terms will be separated, and all the z terms will be separated. That is with the help of separable variable method, right? So therefore, we will get dou square psi by dou x square is equals to minus 8 pi square m by h square into Ex into psi. Similarly, y, that is Ey into psi. Similarly, z, that is Ez into psi. With the help of separable, means where are the x terms will be there, we have to write at one place. So that is, so these are the x terms, right? So this is the x term, we have to write separate. So this is the y term, we have to write separate. This is the y term. This is the z term, we have to write separate. So therefore, we will get three equations, like this is the one equation, this is the second equation, this is the third equation. See these three equations, these all are similar to the particle in one-dimensional box, right? So these three equations are the second order differential equations, and the solution of three second order differential equations can be written with the help of particle in one-dimensional box, right? So this all should be considered as alpha square, alpha x square. Then this is the second order differential equation, and this is called alpha y square. This is the one more second order differential equation, and this is called alpha z square. This is called one more second order differential equation. These all are second order differential equations which are similar to the particle in one dimensional box. Then we know the solution for particle in one dimensional box, that is psi is equals to what? Root 2 by a sin n pi by a into x. But here, along with x-axis, the coordinate will be a. Along with y-axis, the coordinate will be b. Along with z-axis, the coordinate will be c. So that's why psi of x is equals to root 2 by a into psi of x is equals to root 2 by a into sin n pi by a into x. Psi of y is equals to root 2 by b into sin n pi by b into y. Psi of z is equals to root 2 by c into sin n pi by c into z. Right? So these are the individual solutions we are directly writing with respect to the particle in one-dimensional box. Therefore, the overall wave function, the total wave function is the product of psi x, psi y, and psi z. Therefore, psi is equals to psi of x solution is this one, psi of y solution is this one, psi of z solution is this one. The product of all these, we will get the total wave function of the solution. If you able to understand that particle in one dimensional box, it is easy to write, right? So the equation becomes complicated, but if we know the concept, we can write easily. Is it clear?
Yes, sir.
Yes, sir.
You people to want to try to understand how approaching was there, how we are getting the solutions. Later notes will be there. So open the notes and take your notebook and pen. Then you have to write once how it becomes solved, right? You will get the solution from that, right? You have to do practice, otherwise you won't get idea. Okay, right. So this is the wave function. So further we want energy. Further we want energy, right? So what is the energy? We'll see. Okay. We know that energy of one-dimensional box along with x-axis, that is Ex is equals to n square h square by 8ma square. Along with x-axis, that is the nx square h square by 8ma square. Along with y-axis, that is coordinate is b, that's why ny square h square by 8m b square. Vz is equals to n z square h square by 8m c square. Therefore, E total is equals to Ex plus Ey plus Ez. This will be written with the help of particle in one-dimensional box, right? So these all will be written with the help of particle in one-dimensional box. Particle in one-dimensional box. Therefore, total energy E total is equals to Ex plus Ey plus Ez. Therefore, Et is equals to nx square h square by 8ma square plus ny square h square by 8mb square plus nz square h square by 8mc square. Here h square by 8m is the common. Therefore, nx square by a square plus ny square by b square plus nz square by c square. If that three-dimensional box is a cubical box for cubical system, all the coordinates A, B, C are equal, right? So all the three coordinates of A, B, C are equal. So therefore, A is equals to B is equals to C means instead of B, A, instead of C, A. Therefore, nx square plus ny square plus nz square by A square only. If we can take common 8m h square by 8m A square, we will get nx, ny and nz squares, right? This is the total energy of the three-dimensional system. The particle that will be moving in three-dimensional system. The particle that will be moving in three-dimensional system, the energy we will get is equals to h square by 8ma square of nx square plus ny square plus nz square. Now, what is the degeneracy of the system? We'll see, right? Some of the energy levels are having same energy with a different variable substituents, right? Means we can substitute some other different units of nx, ny, nz. We can get a same energy. That becomes degeneracy of the energy levels. This is the important for exam point of view. That is the degeneracy. What is the degeneracy means? Right. For example, this is the energy equation, right? This is the word energy. This is, for example, ground state energy. But some other energies are having same. Means these three are having same energy. These three energy levels are having same energy. For example, two energy levels are there. These two energy levels are having same energy. This is called degeneracy. This is the singly degeneracy. SD means singly degeneracy. Here three are having same, that is triply degeneracy. Here two are having same means that is the doubly degeneracy. So the degeneracy is nothing but energy levels are having same energy. So these energy levels are having same energy, that is called degeneracy. Whether two are having same energy, that is doubly degeneracy. Three are having same energy, that is triply degeneracy. One is having same energy, that means singly degeneracy. Only one energy level will be there, that is called singly degeneracy. So what are the degeneracy energy levels in particle in three-dimensional box? We will see or we will discuss. Okay. Right. See, the phenomenon of showing equal energies that may called as degeneracy of the energy levels, right? Right. We know that the energy in three-dimensional box, that is the equation we have to write first. That is E is equals to, this is the energy for three-dimensional box, E is equals to h square by 8ma square, 8ma square. This is the common. Okay. So what will be variable? Nx square plus ny square plus nz square, nz square. For example, nx is equals to 1, ny is equals to 1, nz is equals to 1. That means 1 square plus 1 square plus 1 square. That becomes 1 plus 1 plus 1, that is 3. E111 is equals to 3h square by 8ma square. This is a singly degenerate energy level, right? So means nx, ny, nz. Nx is equals to 1, ny is equals to 1, nz is equals to 1. You can substitute or you can interchange these values. You can interchange these values, we will get only same energy. So that's why that is a single degeneracy of the energy level. Single degenerate energy level. So just I will show the equation. Right. So we are going to discuss that equation degeneracy. This is the equation. In this equation, we are going to substitute nx, ny and nz values. For example, nx is equals to 1, ny 1, nz 1. We'll get 3h square by 8ma square. That is the degeneracy, single degeneracy. This is the equation. Or else we may substitute nx is equals to 1, ny is equals to 1, nz is equals to 2. Okay. Therefore, E112 is equals to h square by 8ma square of 1 plus 1 plus 2 square means 4. Overall, 6h square by 8ma square. So that is when 1, 1, 2, 1, 1, 2. Or we can interchange these values 1, 2, 1, 1, 2, 1. Nx is equals to 1, ny is equals to 2, nz is equals to 1. Even at the time also we can get the solution same, means energy same. Or one more will be there, that is the 2, 1, 1. That is the 2, 1, 1. Right? 2, 1, 1. So these 2, 1, 1 also having same energy, that is a 6h square by 8ma square. Therefore, we can say these three are having same energy. That's why we can say these are the triply degenerate energy levels, like energy of 112 or energy of 121 or energy of 211. These all are having same energy, that is 6h square by 8ma square. That is triply degenerate energy levels. Triply degenerate energy levels. Okay. So like that 221 or 212 or 122, that are also having same energy levels. So that will be see here, right? So therefore we can plot all those in a energy level diagram. This is about E11, that is a singly degenerate, right? So then 112 or 121 or 211, we can get energy is equals to 6h square by 8ma square. These three are having same energy, that is triply degenerate, right? Or else 221, 122 or 212. These are all are having same energy, that is 9h square by 8ma square. This is also triply degenerate. So then E333 will be there. That is 27H square by 8Ma square. This is a singly degenerate. This is singly degenerate. So this is the degeneracy of the energy levels. This is the degeneracy of the energy levels, right? Is it clear?
Yes, sir.
Okay. So
Yes, sir.
I will give some values. You have to say what is the degeneracy, right? So just you people may take pen and paper. I will give one problem. Just you have to write energy E is equals to S. All of you write it. H square by the 8Ma square of Nx square plus Ny square plus Nz square, right? So this is the energy equation. Now I am giving the conditions of Nx is equals to 1, Ny is equals to 2, Nz is equals to 3. What will be the energy? That is E of 1, 2, 3 is equals to what? E of 1, 2, 3 is equals to what is the energy? Tell me. Nx is 1. This is the 1 means Nx. Okay. Nx is the 1. Ny is the 2. Nz is the 3. Substitute these all 1, 2, 3 in this equation. What you will get energy?
14.
Hmm?
7H square.
7 by 4 MI square. 14H square, sir.
3 square
మనది
means 9. 2 square means 4. 9 plus 4,
14H
13
square.
plus 1.
14.
14H square by
8 MA square.
8Ma.
8Ma square. Okay.
మళ్ళీ అది
8Ma
కొట్టచ్చు కదా
square.
సార్.
Okay. Here
7.
I am going to interchange this one. First Nx is equals to 1 only. Ny is equals to 3.
Thank you.
Nz is equals to 2. Okay.
Okay, sir.
At this time, same energy we will get.
Yes, yes.
Or else we may interchange 2. Nx is equals to 2.
2, 1.
Ny is equals to 1. Nz is equals to 3.
3.
Or Nx is equals to 2 only. Ny is equals to 3. Nz is equals to 1.
1. Same.
Means these 4 times we will get same energy. One more possibility also there. Nx is equals to 3. Ny is equals to 2. Nz
1.
is equals to 1. Or one more possibility is there, that is Nx is equals to 3, Ny is equals to 1, Nz is equals to 2,
2.
right? How many times are there? 1, 2, 3,
5.
4, 5,
6 times.
right? These 6 times energy levels are having same energy of these. Therefore, we can say that the degeneracy is 6. The degeneracy of these energy levels was what?
Same.
6.
Okay, is it clear?
Yes, sir.
Yes, sir.
Definitely the question will come in the examination of these topics like particle in one-dimensional works or Schrodinger derivation or postulates of quantum mechanics or degeneracy in energy levels. After these 4 questions, definitely 1 or 2 questions will be in the examination. Okay. So most important questions from this chapter. Somehow little bit shape of the orbitals and a little bit concept will be there. So that will be discussed in the next class. Okay.
Okay, sir.
Yes, ma. You have to join in the next class, whatever is class you have, right?
Okay,
So
sir. Thank you. Okay,
right
sir.
now, I am going to conclude the meeting, right?
Thank you very much, sir.
Okay, fine.
Okay, sir.
Bye.
Thank you, sir. Namaste.
Yes, okay. You people have to do practice, right?
Okay. Yes, sir.
Okay, okay. I'm going to conclude the meeting. Right. Take care. Happy Sunday to all.